Yeah, maybe you can start with the intro,
Yeah,
Yingjun.
yeah, sure. Yeah, we can start. So yeah, hello everyone. Thanks for attending a webinar. And today we're to be talking about the real-time revolution, comparing the continuous queries, dynamic tables, and they are the live tables. Um, okay, some policies, well, I mean, some housekeeping items. I think, well, probably I don't really want to mention too much about that because for every single webinar, it's like, yeah, this is a policy, right? Okay. And all right, so let's start for our talk. Okay, so today we talk about the continuous queries, dynamic table, and the data live tables. If you're not familiar with these three items, well, then basically I mean, these are all stream processing technologies, well, all products, one lines, well, proposed by Google, BigQuery, and Snowflake and Databricks. So there are similarity, definitely there are similarities, but well, there are also lots of differences, and we'll definitely cover that in this talk. So I'm Yingjun Wu and a founder of RisingWave Labs. So RisingWave is a stream processing company. And prior to starting this company, I was at AWS Shift and IBM Research Amazon. People always ask me about, okay, why you working on stream processing, right? I mean, one of the reasons is that's definitely probably not a major reason, but one of the reasons is that's why I did my PhD in stream processing and database systems. So, and over the last few years, I feel that, okay, we feel that, okay, this domain is super excited. So we started this company 3.5 years, almost 4 years ago, and started to develop our product. So this project has been, we're doing great. And so we have already building the so-called the SQL platform for event-driven workloads. And so that people can do all these kind of like event-driven workloads or event-driven applications for inside using RisingWave. So I'm not sure whether everyone is familiar with event-driven workloads, but for essentially it covers basically everything. For example, let's say if you are doing stock marketing, market trading, or probably you're doing something like, okay, the sports betting, then probably you really want to do the streaming analytics over your stock market data, right? That's the streaming analytics, and that's event-driven, right? Where every time a new tick comes in to your, I mean, to from the stock market, will you probably want to do some processing, right? Do some analytics. And if you want to build something like monitoring and alerting applications, then it's event-driven application. For example, for fraud detection, every time a new event comes in, you probably really want to trigger the computation and detect, okay, whether it's a fraud or not. And for real-time ETL, it's more, yeah, probably, people are more familiar with that term. Yeah, that's basically data enrichment, right? And you can get the data from different sources and doing joins, and then probably send the data into downstreaming systems. And there are many others. I probably would not mention it here. And RisingWave is open source for system, and it's released on the Apache 2.0 license. So just one picture about what RisingWave is. Basically, you can consume data from the event streams or Kafka database CDC like Postgres CDC or from the batch sources. You can do joins. You can do joins on the fly. You can do aggregations. You can do anything basically on the fly, and then totally depending on your use cases, you can directly use RisingWave to serve your online applications or serve your online real-time dashboard, or probably dump the result into your analytical systems like Snowflake, Databricks, or Redshift, or some others, right? So basically, that's RisingWave. So, okay, so RisingWave is a stream processing system, and today we also talk about the stream processing technologies in different systems, especially coming from the big companies. So before talking about those technology, let's first compare the batch system and batch processing and the stream processing. For batch processing, basically what you do is that, let's say, imagine that we have a table, right? Well, let's say we have four rows, 4 items in this table. So every time we want to do computation, we do a 4 table scan. Basically, you have to scan the table one row by row, right? Or item by item and do the calculation. That's how it works in batch processing system. And so let's say that if I have multiple comps in, and next time if I want to do analytics, I still have to process from the scaling entire table and process from the very beginning. So if you want to have something like scheduled computation, then probably you can use some orchestration tools such as Airflow, right, to orchestrate and to set the timers, right, for every single hour, let's trigger the computation and generate the results. That's batch processing. But stream processing is totally different in that it's like event-driven computation. Basically, every time a new event comes in, you do the computation, right? Let's say that this will Alice the row ID 1103 comes in, you update the results, right? And then a new tuple comes in, you update the result. Basically, that's stream processing. So you can see the huge difference for the computation model between the batch processing and stream processing. So about the use cases. So I mean, fraud detection definitely is a great use case. Stock market data dashboarding, right? And IoT data monitoring, alerting, right? And in Google, they just announced the continuous queries, and their use case is like, the shopping cart, right? Imagine that you are running an e-commerce company, and your customers can probably just have left a lot of items in their shopping cart, right? If they do not really pay, then it basically becomes the abandoned online shopping cart. And Google says that, well, no, I mean, we actually left a lot of money there. Actually, 70% of the transactions were actually abandoned. So Google says that, okay, no, let's focus on that, or let's optimize that part. So they introduced something called the continuous query, which can detect the new items, new events inserted into the so-called here is called abandoned cart event table, and then do processing, and then send the events to the pop-up notification system. And then with the notification, we can send probably our customers a coupon, right? Well, let's say 20% discount or $7 off, right? Well, this kind of coupons. So that's what we can probably the customers could come back and pay for their shopping cart, right? That's the use case mentioned by Google. Okay, stream processing is definitely not a new, but the interesting part is that for big vendors like Google BigQuery, Snowflake, and Databricks just released the stream processing product lines for recently within these 2 years. For Google, I mean, they just released it for last week, and it's still under preview. It's not a GA yet, but it's still under preview called continuous query. For Snowflake, it's dynamic tables, and it's not also not an old product. It's just a 4 months old, right? It's GA on April the 29th, and just literally 4 months. For Databricks, well, I mean, they have a pretty solid product called Delta Live Tables, and it was released recently 2 years ago. So we can see that, these guys were always, but no matter which vendor, they just started working on the continuous queries or stream processing, introduced the stream processing technology into their product line, right? And we definitely want to compare the differences when the similarities occurs with different technologies, right? So yeah, let's dive deeper into that part. But before that, I have to mention that all these analyses are based on the public available information found online before August the 14th this year, and because I know that they can definitely have some decorative secrets, or probably they have some hidden features that I'm not aware of. I mean, so I have to say that all these analytics are based on the public information. Okay. And it's definitely this article is definitely not intended to serve as the advice for purchasing any of these products. Okay. Okay, so let's evaluate these three different systems, right? And we evaluate from multiple dimensions, but data source, data sink, and basically for data source, it means that where the data can come from, right? And data sink means that where the data can be sent to. And SQL capabilities, okay, whether it's like limited for functionality, it only allows limited functionality, or it's like, okay, allows all different kind of SQLs, right? So SQL queries, right? For freshness, whether it's like second level latency or probably 10-minute latency latency, and for fault tolerance and the damage scaling is these are also pretty interesting dimensions we want to dive into, right? For example, if your system crashes, what will happen, right? So yeah, let's dive deeper into these dimensions. The first system we will evaluate is continuous queries. Continuous queries, as just mentioned, was just released last week, and it was released by Google BigQuery. And the purpose of it was to continuously analyze the perform the continuous analytical processing. And they also mentioned a lot about the Gen AI. I can talk a little bit more about that part. They mentioned the Gen AI for real-time application development, and also reverse ETL into operational systems. So for reverse ETL into operational systems, you can imagine that, okay, we have, let's say, let's reuse the abandoned cart for example, right? We can essentially have, so let's say that we have the, we notify, we notice that, okay, a customer just left some items in their shopping cart. Then essentially we can check with our checking our in here in BigQuery use case, where it's like, okay, we can check the customer's information inside or stored inside of the BigQuery table and check, okay, whether the customer is willing to pay for the shopping cart, right? And if let's say that's where it's just the customer's habit to lift anything in the shopping cart, then we don't need to do anything, right? But for if the customer is just like, okay, price sensitive, cost sensitive, then probably we can send them a coupon, right? And then we can send the information back to the operational database that serves the application, right? So this is a reverse ETL use case. So, okay. And for BigQueries, let's talk about, okay, where the data can come from. So the BigQuery explicitly mentioned that they only, if you want to use continuous queries, the only source allowed is essentially BigQuery tables. So if you want to use BigQueries, you cannot directly connect your Kafka to the BigQuery table. You cannot do that. The only way you can do is that we can have to dump the data into the BigQuery table and then use the continuous queries to consume the table, consume the results from the BigQuery table. That's pretty limited, right? Well, that's that's your product. And I think one of the reasons here is that, I mean, if you want to BigQuery continuous queries need to identify the delta, right, for the new events. And probably at the moment, for the only way for them to identify the new event is to check for the table logs, right, the write log, so that's where they can know, okay, which data is newly inserted, right? So, okay, then people may ask, okay, how can I insert the data into BigQuery tables? So Google mentioned there are several ways to load the data into BigQuery table. The first one is that, okay, the BigQuery store write API. And second one is, well, okay, you can call a function called the table data dot insert all method and batch load. Definitely you can use conventional database for the insert DML statement. It's basically quite straightforward, right? It's like just insert the data into it. So yeah, back to the data sources. Where if you want to use the BigQuery tables, BigQuery continuous queries, you actually have to first load the data into your BigQuery table. That's the only way you can use BigQuery continuous query. You cannot directly connect your Kafka into the BigQuery continuous queries. It's not permitted. Okay. So for data sync, okay, let's say that, okay, we process the queries, right? Well, after processing a query, where I can send the results to, right? There are only three destinations allowed in BigQuery. The first one is BigQuery table. So basically, let's say that you consume the table. Let's say that you are running a BigQuery continuous query on top of a BigQuery table. You can directly send the result into another table. That's a valid operation. You can do that. The other way is that you can send it to a Google pops up. As I just mentioned earlier, I mean, BigQuery actually allows you to do the reverse ETL, right? Well, how that works. Essentially, it's like, okay, you can send the data from BigQuery table to a PubSub so that we can connect a PubSub. You can use your PubSub to connect to a downstreaming operational database. For example, MySQL, probably, for example, the Postgres. So, and use that database to power your online applications. That's how it works. And third destination, yeah, I'm not sure whether it's popular enough, but I mean, you can definitely dump the result into the Google Big Table, right? So yeah, these are the three destinations allowed by the big continuous queries. Then let's talk about the SQL capabilities. Well, I have to say that I think the product is kind of like still early stage when it's super limited in terms of the SQL capabilities. The only operations it allows with just a stateless operations like probably filtering or projection, these kind of operations. And definitely it also allows you to do insert statements. So basically you can use the insert statement to insert data into the BigQuery table. That's something you can do within the BigQuery continuous queries. But and the other thing mentioned by Google is that, okay, you can call the GenAI function. Because, well, I mean, coming back to the Google's data stack, you will immediately find that they promote their GenAI, the LLM a lot, right? So essentially, once a tuple comes in, you can just call the GenAI function like ml.generate text or generate embedding. Call these two functions to generate the result, generate the generate output, and then send the output to the downstreaming system, right? So imagine that you have something like, okay, the event streams, right? Event streams come, let's say the user's prompt, right? You can definitely I mean call the GenAI their GenAI function and then generate the results. They didn't really mention, Google didn't really mention specific use cases, but I think you can imagine that probably there are a lot of use cases. But in general, I have to say that their their continuous query is kind of like at the moment is kind of very limited in terms of the functionalities supported. And you cannot use the continuous queries to do any stateful operations. Like you cannot do joins, you cannot do aggregations, you cannot do window functions, you cannot do any of these stateful operations. Okay, that's the limitation. That's a huge limitation in my opinion. So in terms of freshness, now we are unable to find any information and it's still under preview. So the only way to get access to the product is to contact their sales team and ask for the preview permission. So that's the only way. So their documentation didn't really mention anything about the freshness. So I have to say that it's not available. There's no information available at all. And what about the fault tolerance? Well, though there's no information at all, I have to say that definitely I believe that they can support for instant failure recovery. But the reason is that all the queries actually supported stateless operations like filtering, like projection, right? Well, so it's kind of pretty straightforward to recover from the failures. And what about the dynamic scaling? Well, Google explicitly mentioned that with continuous queries can be configured to use auto scaling. So it means that you have to provision in advance. That's probably another limitation. And you have to understand your workload. You have to understand your, So you have to understand how much traffic you're expecting, right? Definitely, it's probably not easy. But in general, it's you cannot configure a continuous query to use auto scaling. And to summarize, well, Google's BigQuery is definitely a pretty young product, and it's very limited in terms of data sources. I mean, it only can ingest the data from BigQuery tables and sinks. Well, I mean, it's also pretty limited. It only allows 3 types of sinks. And SQL capabilities it only allows databases functionalities and as well as calling their Gen AI API. That's the only thing they allowed. But well, I mean, definitely it's good, pretty good for calling Google's Gen AI APIs, right? Let's say that if you want to, if you really want to use Google's AI model, then you don't need to write your own application. You can just use Google's continuous query to do that. And it's not suitable for executing complex queries. Let's say that if you want to join multiple tables, no, don't use Google continuous query because it doesn't really support that at all. Okay, that's a summary for the continuous queries. The second technology we want to evaluate is dynamic tables in Snowflake. So this is the diagram I got from the Snowflake website. So as I mentioned, well, basically it's as the name implicates, right? Well, basically it's like, okay, the dynamic table that can automatically refresh, right? So let's look at for the first. So let's look at where you can send the data into the dynamic table. So again, I think it's kind of like similar to the to BigQuery. The data sources is kind of like limited. The only 3 sources it allowed first base table, base objects, right? Base objects could be a materialized view, or probably could be a standard, a Snowflake table, right? Well, if you have a table, you can build a dynamic table on top of it, but you cannot directly, let's say, connect your dynamic table with, let's say, a Kafka or probably with your Postgres CDC. It's not allowed. And you cannot directly load let's say, the data from CSV files, a bunch of CSV files into a dynamic table. It's not allowed at all. So and another data source is dynamic table itself. I think I will just mention later that you can essentially use you can essentially do the computation and then deliver the result into another dynamic table. Another data source that interests us for long is actually iceberg tables. So as you may know, Snowflake just mentioned that they will have their own they probably have already announced they have already announced their own the catalog thing, right? For the data lake catalog thing, and they were investing in the iceberg direction. So they will allow people to ingest the data from iceberg tables. Let's say that if we have a table stored in the stored in S3, but with iceberg format, iceberg data format, you can essentially use a dynamic table to ingest the data from iceberg table. This is very interesting. Why? Because Iceberg actually itself doesn't really support the CTC. So basically, you cannot easily detect the changes within the Iceberg table. So that's pretty interesting. And so you can imagine that it's not easy, right? But Snowflake also mentioned that if you want to use Iceberg tables as a source, Iceberg table must be a Snowflake managed Iceberg table. That's the requirement. And you cannot, self-host for the iceberg table, right? Or probably use some other vendor's iceberg table. You cannot do that. The only way you can do it that use Snowflake's managed iceberg tables as the data source. And what about the data sync? Well, after computation, where I can send the data to, right? There are 2 destinations. The first one is I just mentioned dynamic tables, right? You can consume the data. You can consume the data from dynamic table, do computations, and then store the result into another dynamic table, right? So that's first sync destination, and the second destination is dynamic iceberg tables, right? So basically, let's say that if you have a table stored in iceberg format, you can essentially do computations and then dump the result into another iceberg table. that's pretty interesting, right? Because what essentially the you can capture the change from the upstream delta life sorry, not delta life table, the iceberg table, and then do computations and then refresh your the downstream iceberg tables. That's pretty interesting. But I have to mention that first, it's still a preview feature, and second, it's like it's you have to use Snowflake manage the iceberg table. You cannot use any other vendors manage the table. You cannot use your own manage the iceberg table. You cannot do that. So yeah, that's the dynamic tables data things. Then what about the SQL capabilities? Well, dynamic table is kind of like they follow most of the queries. I have to say that. So you can see that the only unsupported constructor operators and functions are this like pivot, set operators. Well, probably union all, right? All the joins for these complex query, these complex operators, right? Yeah, but why they can support so many applications? Why they can support so many queries? Well, the interesting part is that, they actually do not really just use a stream processing engine. They actually also do the batch stuff. So basically, once let's say once some changes occurred, right? I detect these changes. Snowflake will not guarantee that it will be incrementally executed. It could be batch executed. Basically mean that I just refresh the entire table by doing the recomputation, right? And the only queries that are incrementally executed could be basically the where having qualify and probably some of the join operators, union or group by. They support, they can execute these queries incrementally. Yeah, and what about the freshness? So as I just mentioned, well, they actually under the hood, but they actually have both the streaming or incremental computation engine and the batch computation engine, right? So the users can essentially set the freshness. You can just tune the freshness. The first way is that you can just let the Snowflake know that refresh my table every single hour. You can do that, and you can just use this query like alter dynamic table product set a target lag to 1 hour, right? But another interesting case is that let's say that if you have the dynamic table built on top of another dynamic table, then essentially you can set a so-called target lag this parameter to the downstream, meaning that let's say that for the TD2 dynamic table 2 it's refreshed every single hour. You can just let a TD1 to be refreshed whenever TD2 is refreshed. So using this query, you will be allowed to, automatically refresh the TD1 dynamic table, the upstream dynamic table, and whenever dynamic table 2 is refreshed, we will refresh dynamic table 1. So that's the freshness. Well, that's how you can set a freshness, right? And what about the fault tolerance? So using Snowflake, if you want to do the incremental computation, or if you want to, sorry, not the dynamic scaling, sorry, not the dynamic scaling. If you want to do the dynamic table, then essentially you have to have the virtual warehouse. So dynamic table is in the documentation, they explicitly mentioned that dynamic tables require virtual warehouse to refresh. So you can imagine that, let's say so let's say that if one single virtual warehouse just get crashed, then you don't need to worry about that because Snowflake will directly create another dynamic table for you. The virtual warehouse for you. So that's a dynamic table, right? So what about fault tolerance, right? What about the dynamic scaling? So everyone knows that Snowflake has the so-called decoupled compute and storage architecture, and which means that you can scale in and out your dynamic table warehouse or the virtual warehouse at a runtime, right? So it definitely supports dynamic scaling. So that's a pretty interesting part. But But yeah, one thing people, but one point I would like to mention is that in dynamic table in Snowflake they also support another technology called materialized view, right? So in RisingWave we also support materialized views. Well, in Postgres they also support materialized views, but be aware. So you have to know you have to notice that okay the materialized views in Snowflake is different from materialized views in any other systems, like, or at least different from Postgres, different from RisingWave, different from any other systems. In that, their materialized view based on their computation only supports single table. A materialized view can only use a single table, base table. So basically, let's say that you have a base table, you can only create a materialized view to do some aggregations on top of that table. You cannot join two different tables. But for dynamic table, the different part is that it's more advanced materialized views in Snowflake. A dynamic table can be based on complex query, including joins and unions, meaning that okay, you can have, let's say that we'll build a dynamic table on top of, let's say, 3 different base tables, right? But I have to say that, well, I mean, in any other database systems, well, their materialized view concept is essentially the Snowflake's dynamic table concept. So there's no dynamic table is just like a standard materialized view. Well, Snowflake's original materialized view is more like okay the kind of like limited version of the conventional the materialized view in conventional database systems like Postgres. Right. So this is the limitation you have to understand. Or is this tricks? All right. Well, this is kind of like tricks you have to understand whenever using Snowflake's materialized views. It's not real materialized view, it's just some aggregation tables, pre-aggregation tables, and their dynamic table is the real materialized view. So that's the trick you have to understand. Okay. And another interesting point that is that I mean Snowflake's it could be extensive. The reason here is that if you want to refresh the dynamic tables, you actually have to create an additional virtual warehouse. You have to be very cautious, well, which means that okay, let's say that you have if you are using 4 virtual warehouses, right? So if you want to refresh the dynamic table at scale, you probably have to create additional virtual warehouses, which means that we actually need to spend more money. Be very cautious. Yeah, when you use this functionality, because you actually need to pay additional money. So let's talk about the Delta Live tables, right, in Databricks. Databricks, this product was first released actually 2 years ago. As she mentioned, it was released the GA in 2022, I think April 2022, right? Databricks Delta Live table is in this figure you can see that this support continuous or scheduled ingestion from the upstream services, right, and do all this kind of fancy stuff, right, and then generate result into they call it go zone, right, and so that you can directly use the results to power your, let's say, the BI tools, or probably AI machine learning, or probably data sharing. That's the Delta Live table, right? So let's dive deep into the Delta Live table, what it means. So the first thing I have to mention that I really like their data sources. Well, they actually support a bunch of data sources. They allow you to have they have the functionality called auto loader. So basically, let's say that if you have a S3 bucket, it will allow you to load the new files from the cloud storage automatically. Right, it will detect a new files and load it into Databricks. And the second thing is streaming tables. Well, I will probably not spend too much time on this topic because streaming table is their Databricks concept. And the third thing is cloud storage messaging process and external systems. So basically, it allows you to ingest the data from, let's say, Kafka, from Powder, from other messaging queues, and you can also store your data, let's say, in, as mentioned, probably S3, right? And probably some other batch-based systems, right? You can do that. And they also support CDC, the change data capture, meaning that let's say that if you have operational database like Postgres or MySQL, they can actually capture the data changes, and then load the changes into the Databricks. That's super powerful, right? And so yeah, so you can see that compared to the previous two systems, the Databricks and comparing to Snowflake and the BigQuery as well. Databricks actually support many more data sources, right? Basically all these kind of different sources. That's pretty cool. And what about the sync? Well, in terms of the sync, I have to say that's where it's kind of like limited, well, even more limited compared to BigQuery and compared to BigQuery. So because for BigQuery, it actually essentially allows you to send the data into PubSub, which is essentially a messaging queue, right? Through the PubSub, you can send the data to anywhere, right? But for Delta Live Table, it actually doesn't really allow you to do that. The only way you can do it is that you can write the data as a Delta table. So I mean, so note that Delta Live Table is different from Delta Table. So basically, in Databricks, they have a concept called the Delta Lake, right? So yeah, Delta Lake. Yeah, you can imagine that Delta Table is is a table on top of a Delta Lake. That's it. It's different from the Delta Live Table. I have to mention that. So you can definitely write the data as a Delta table. That's the first way you can do. And that's but actually that's probably the only way you can do. You can only send the data into the Delta table. You cannot send the data into upstream sinks. At least I could not find any documentation mentioning that they allow you to do that. Well, I think that's probably the only way. But I have to mention that for the Delta Lake, they actually support the CDC, which means that probably you can implement your own CDC tools, which could be tricky, but you can do that. You can implement your own CDC tools and to detect the changes, and then to detect the changes and then feed the changes into your downstream system like Kafka, like Powder, like whatever, right? That's possible. That's not, that's possible, but we have to work on do it on our own. There's no tools provided by Databricks. They do not really allow you to do that. And what about the SQL capabilities? I have to say that, I mean, they support most of the queries. And the reason here is that the under the hood is essentially they actually use the Spark streaming, Spark structure streaming. So Spark structure streaming is like it's more like a streaming version of the Spark, right? So you can use any, and it's basically the computation model is mini batch based, right? Basically, it's like chunk different big batch into a small a bunch of like smaller batches, right? So mini batches, right? And then do computation. So but for Databricks, well, I mean for Spark, we don't definitely support lots of queries, right? And most of the queries, I have to say, right? Well, so for Delta Live Table, yes, well, yes, similar to the Spark streaming, they support most of the queries. And in terms of freshness, we have to say that it's like, because they use the Delta Live Table as the sorry, not the Spark streaming as the underlying execution engine. So it actually supports sub-second latency, meaning that I think that's probably the best case, right? Meaning that so if you ingest the data, let's say from Kafka, you can see the result immediately within seconds. But I have to mention that that's probably some best cases, because there are some open benchmark comparing Spark streaming with some other systems, and one of the conclusions drawn by many other people is that Spark streaming is not very good for the freshness, right? That's there. I mean, there are some publications, and I probably prefer not commenting on that part, but you can search online. And I can only mention what they claimed. I cannot provide any evidence, right? Okay, and in terms of fault tolerance, that's also a pretty interesting topic, because for Spark, right? Well, it actually does not really need to. It actually uses the so-called mini batch mechanism, right? So that you can actually recover from the fault tolerance failures instantly. That's pretty cool. That's definitely a pretty cool part. Or at least I cannot say instantly, but at least you can recover it from in parallel, because it's basically recover from a bunch of mini batches. So you can do that. And in terms of dynamic scaling, similarly, it uses the structural streaming as an underlying execution engine. It actually supports for the parallel recompilation and dynamic scaling. To summarize, so for Delta Live Table, I have to say that we definitely support for ingesting data from various data sources. That's pretty cool. That's much more powerful than any other systems or any other, at least compared to the continuous queries in BigQuery, Google's BigQuery and the Snowflake's dynamo table. But it cannot sync data outside of Databricks. So if you use Databricks, that's cool. You can probably use Databricks to do anything, right? But if you have any other system like your own self-hosted, let's say, Elasticsearch will probably, some other products, AWS product, or probably some third-party products, you cannot use it. You cannot sync the data outside of Databricks. It just, as just mentioned, probably yes, it's possible. The only way you can do that way is probably you can ingest the data from their data lake. That's possible, but you have to do it on your own. And because what Delta Live Tables uses the spectral streaming as an underlying execution engine, it supports expensive SQL query capabilities. That's Delta Live Table. Cool. Yeah, let's conclude. So we have we have continuous queries in BigQuery table of Google's BigQuery table, right? And dynamic tables from Snowflake and Delta Live tables from Databricks. And we also have RisingWave, because RisingWave is also a stream processing engine, but it's like basically it's not tied with any of these big vendors. So the first thing we can look at is that for BigQueries, I have to say, continuous queries, I have to say that the data sources is very pretty limited, because it only allows you to ingest the data from the BigQuery's table. For data syncs, it only supports you can sync the data into another BigQuery table, or probably you can send the data into the big table, and probably you can send the data into PubSub, but you cannot send it to any other places, right? In terms of SQL capabilities, it's also very limited. It does not really support any of these stateless or stateful computations. You cannot do joins, you cannot do aggregations, time window functions. For freshness, well, there's no mention. They do not really mention that. For fault tolerance, they also didn't really mention. But for dynamic scaling, they mentioned that you cannot do auto scaling. In terms of dynamic tables in Snowflake, I mean, the source is also pretty limited, and in the sync, well, it also does not really allow you to sync the data to external data systems. So if you use Snowflake, then you have to, everything is within the Snowflake ecosystem. That's pretty limited. And for SQL capabilities, it's pretty extensive. And for freshness, tunable. Know that you can probably tune it to set it to 1 hour, probably 24 hours. And for fault tolerance, that's yes and yes. Delta Live Table, the data source, we can ingest the data from multiple different sources, right? From CDC, from the Postgres CDC, from the S3, from the, say, the messaging queue, from anywhere. You can do that. But for the limitation is that, I mean, you cannot sync the data outside of the Databricks. So that's the limitation. That's probably a huge limitation. For SQL capabilities, well, I mean, it's kind of extensive, and for freshness, some second, right? And here we also compare all these three different systems with RisingWave. For RisingWave, we actually support for all these kind of interesting data from all different systems. We actually have already supported almost 20 different systems, like including but not limited to Kafka, Pulsar, all these kind of messaging queues, and also Postgres CDC, MySQL CDC, MongoDB CDC, all these different systems, and also definitely S3, right, for the Iceberg. And for data sync, well, I mean, we allow people to sync the data into any downstreaming systems like Snowflake, like Redshift, like Databricks, like BigQuery, anywhere. And in terms of SQL capabilities, RisingWave is Postgres compatible. So as long as Postgres supports that, we highly likely that we also support that. For freshness, we can be as low as, I mentioned here as sub-second, but we can do as low as, well, let's say 10 milliseconds or even single-digit milliseconds. Well, totally depends on use case. And for fault tolerance, we can support instant failure recovery, and we also support for the dynamic scaling at the runtime. Cool, yeah, that's a comparison among all these 4 different systems, and that's also on my talk. So if you have any questions, feel free to ask, and you're also more than welcome to join our Slack community, risingwave.com/Slack, and you can feel free to ask any questions there. Thanks. Ivana, you are muted.
Yep, sorry about that. Let's just give people some more time if they want to ask a question. And as Yingjun have said, like, you can always join our Slack and ask your question there.
Yeah, so actually one question, I was told I was asking that, so essentially in the Delta Live table, does it support with the so basically the tunable, what do you call it? Support the tunable freshness. The answer is probably is I think I have to say that, well, for Spark streaming, it actually supports tunable latency. Basically, you can set a parameter, right, to set a freshness, and basically you can set the mini batch size. But here in the documentation, they didn't really explicitly mention that. Probably because, well, one of the reason is that they probably want to mask that out. You probably don't really want to expose so many parameters to that up to the users. Okay, the question about the cost, well, in terms of the cost, well, for Databricks, well, you have to, so Databricks Delta Live Table is more expensive than the Spark streaming. So the reason here is that, well, it doesn't just require the Delta Live tables for the Spark streaming engine. It also requires more engines. Well, one is that, well, they actually requires to have the ingesting sources. And they also require the other one I've got, but, well, essentially they require you to turn on multiple different engines. So it's way more. It could be way more expensive. Probably not way more, but, well, it's definitely more expensive than the Spark streaming. So that's something you probably have to be very cautious. And I just mentioned for Delta Live, for the dynamic table as well, similarly, it's like, yeah, it's also could be more expensive. And for the continuous queries, well, they didn't really mention the pricing yet. So yeah, so that's cool.
Another question, Yingjun.
Okay, so so one question is that you want to ask why RisingWave could achieve superior product features compared to your competitors. I mean, because we are focused on stream processing. So basically, for every single product, they have focus, and RisingWave is super focused on the stream processing domain, and so that's why we spend basically almost all our bandwidth, or I mean the R&D efforts in the stream processing. So that's why we definitely are more capable in handling the stream processing workloads. So for example, I mean, in terms of if you compare to, and we position ourselves as more like an independent vendor. We do not really want to be let people to feel that they got a vendor lock-in, right? So we actually support with open ecosystem. Let's say that if you use Iceberg, for sure you can do that. If you use Data Lake, for sure you can do that. And we do not really ask you to pick one side. You only have to use Snowflake. You only have to use Databricks. No, we do not really do that. And yeah, that's and we do not really do something like machine learning. We do not really train machine learning model. If we want to check Databricks, they actually have a machine learning model, right? We do not really do that. We're pretty focused on stream processing. That's probably one of the key reasons why we are more capable in terms of the stream processing functionalities. Okay, support serverless capabilities. Well, okay, so the question here is that whether any other vendors support serverless capabilities. So for so for Snowflake, well, so for Snowflake, well, I mean, the so-called virtual warehouses always they claim themselves as serverless, right? Yeah, you can judge, right? Well, I mean, you whether it's serverless or not. Well, I mean, it's virtual warehouse. Basically, you can dynamically change the number of virtual warehouses or the size of the virtual warehouses you have, right? And so I cannot comment on that part. Well, totally depend on your definition. But for Databricks, well, I mean, if you are a Databricks customer, you know that well, Databricks mainly support BULC, and they do support serverless. They claim that they support serverless, and but their serverless is more about okay, you can run a certain query using a serverless manner, right? So basically, pay as you go, right? You run this query and you pay this amount of money. That's their definition of serverless. And for continuous queries, they didn't really mention at all. No pricing at all. Okay, and does RisingWave write its own stream processing engine or did it deliver? No, we have our own stream processing engine because we didn't really think that we don't really think that yeah, we are Postgres first. Well, I mean, there are several reasons that drive us to implement our own streaming engine. The first one is that I mean, we want to be Postgres compatible. And because we believe that the ecosystem is super important in modern days. And we don't really want to have so-called dialect or whatever, right? Or SQL dialect, KSQLDB, probably Flink or probably Spark Streaming. No, we don't really want to do that. And we want to be Postgres compatible. And second key reason here is that we are none of these existing systems, right, just mentioned to cloud native, so-called cloud native that, well, look, imagine that for the cloud, we have the EC2 instances as the computation engine, where the S3 as the storage engine, right? And so none of these systems were built in that style. They actually have, for KSQLDB, Spark Streaming, Flink, well, so basically they do not really do that, and they do not really store their state in S3. So, but we believe that okay, the cloud native is definitely the way to go, and that's why we build our own engine, and that's the only way we try to adopt a different use different engine at the very beginning 4 years ago, but no, we found that it's not possible. Okay, and do you know if BigQuery and Snowflake uses the same batch engine or different engine on the hood? So definitely, I mean, BigQuery and Snowflake definitely have their own engines, right? So that's for sure. And I believe that for the continuous query, it seems that because it's very limited. So I believe that it's not a batch engine; it's probably a streaming engine. But for Snowflake, as I just mentioned, because everything is tunable, and it's more like okay, batch refresh, and that's essentially I think that's super similar to the materialized views in Redshift. It's super similar, and so I believe that's the Snowflake. If you ask me about the Snowflake batch, okay, just mention the dynamic table, the batch engine. I believe that's it's super similar to the the Redshift materialized view. And for continuous queries in BigQuery, I believe that's it's a streaming engine. How does Flink stack up in this comparison? Okay, for Flink, I think okay, so for Flink, they do support different data sources, that's for sure. And data sync, yes, they also support data syncs. But data syncs, I mean, it totally depends on vendors, right? Or the open source version, you have to check. Right, that's for sure. I cannot speak for any of these vendors, but you have to check. For SQL capabilities, I have to say that it's definitely a subset of any of these systems. Well, subset. It's not a superset. It's subset of any of these systems because okay, for the first three, you can imagine. I mean, for BigQuery, it's definitely continuous queries is definitely very limited. But as just mentioned, for Snowflake and Databricks, they are super powerful, right? And they support all kinds of the queries. And for RisingWave, we support Postgres queries, so PostgreSQL. So you can imagine how powerful PostgreSQL is. And for Flink, you can imagine that, okay, the limitations, you can estimate, right? Where you can feel the limitations there, right? And in terms of freshness, yes, for Flink, well, it does not, the freshness, it could be sub-second. And for fault tolerance, that's an interesting part. Well, they claim that was part of fault tolerance, but I have to say that, well, it totally depends on the failure recovery time, totally depends on the state size. And well, the internal state, where it's not transparent at all, you actually have to tune the state on your own. And if the state is big, then the failure recovery time could be very, very long, very, very long, could be hours. Totally depends on your applications. And for dynamic scaling, similar to failure recovery or fault tolerance, totally that's proportional to your state size. If your state is big enough, then it could take hours or probably 30 minutes. Totally depends on your state size. But for RisingWave, it's just a second level failure recovery. Second level. Basically, the system failed. Boom, it recovered. That's it. The key reason here, that's if you ask me why, the key reason here is that we store the state in S3, and everything is S3 based, and so yeah, we can ship that. But if you use any other stream processing engines, no, you have to. It's definitely the recovery time and the dynamic scaling time is proportional to your state size. Okay, so another question is that there are two ways to achieve the unified batch and streaming in various systems. One is through the unified computation engine, and the other one is using various data formats, storage formats like Hoodie, Data Lake, and Iceberg. How do you compare these two ways from unified batch and streaming? Yeah, okay. So I believe that, okay, for most of the query engines in the future, I believe that, well, I mean, if they are future facing, I mean, query engines, then I believe that's where they will support both batch processing and stream processing. For example, in RisingWave, we actually support both batch processing and stream processing. But if you ask me about the storage format, well, I mean, I probably could not comment too much on that part because for every single vendor, they have their own strategy. But as far as no, I mean, you mentioned Hoodie, Data Lake, and Iceberg. What I know is that, I mean, Hoodie is kind of like, yeah, people are talking good things about their streaming ingestion. Yeah, it's good for streaming. Data Lake, yeah, probably, yeah, people also talk about the streaming, yeah, the streaming capability, yeah, you can write for ingest a huge amount of data directly into Data Lake. People mentioned that part. For Iceberg, well, I mean, it's kind of like, yeah, not that streaming, but for the but I have to say that, well, I mean, the system is improving. I have already seen a bunch of let's say the PRs or issues will mention that part, and Iceberg definitely is catching up. And in terms of, I mean, in terms of the streaming processing in terms of streaming ingestion capability, they're definitely catching up. And in terms of CDC, I think, well, the Data Lake support CDC and Hoodie. I remember, if I remember correctly, but feel free to correct me if I got wrong. I remember Hoodie actually also supports CDC. While the Iceberg, I think probably they also have plans to support that, but at the moment, probably no. Yeah. All right. I think we run out of time, right?
Yeah, we're on time and we managed to answer all the questions. Thank you, everyone. Thank you for attending, and please be with us next week.
All right. Thank you. Yeah. Bye-bye.